Students, hope you all are doing well. So we'll continue with chapter 2, that is solution chapter. So today we'll start with molality. So molality is defined as number of moles of solute per kg solvent. Mathematically, it is represented as M is equal to number of moles of solute. In the last class we studied number of moles is given by NB, where B means solute, N means number of moles, divided by. Now here it's per kg solvent, that means mass of solvent. So we'll use WA. And this should be in kg. Or we can write NB WA. Instead of using here in kg, you can multiply here by 1000. NB we can write WB by MB, that is mass of solute by molar mass of solute. So this is WA. And this is multiplied by mass of solvent, multiplied by 1000. So this is the formula of molality. Now molality is temperature independent. That means molality is not dependent on temperature. So let us take a numerical. The question is calculate the molality of 2.5 gram of CH3COOH. Is known as acetic acid or ethanoic acid in 75 gram of benzene. So again, since we are going to do a numerical, the first thing you do, you write down the formula. So you're asked to calculate molality, so you'll write down the formula of molality. So it's M, small letter M, represents molality, is equal to WB, that is mass of solute, by MB, molar mass of solute, multiplied by WA, that is mass of solvent, and is multiplied by 1000. Now, according to the question, 2.5 gram of CH3COH in 75 gram of benzene. That means acetic acid is dissolved in benzene. So acetic acid is solute, benzene is solvent. So it's given 2.5 gram of CH3COOH. That is mass of solute. WB is equal to 2.5 gram. Next, MB. You need to find out the molar mass. So you have the formula. The formula is CH3COH. So you know how to calculate the molar mass of a compound. So carbon 12 plus hydrogen is 1 multiplied by 3 plus again you have carbon, so 12 plus oxygen is 16. You have 2 oxygens, so 16 multiplied by 2 plus 1. It is 12 plus 3 plus 12 plus 32 plus 1. So if you calculate, you will get 60 gram per mole. Mass of solvent, that is WA, is given 75 gram. So therefore, molality M is equal to mass of solute 2.5 grams multiplied by 1000. Molar mass of solute is 60 gram per mole. And mass of solvent is 75 gram per mole. So 75 gram. So if you simplify this, you'll get 0.556 mole per kg. So you can take some more numerical problems from the textbook or from question bank and practice yourself. Let us see the next concentration term, that is mole fraction. In mole fraction, we take components. We can take two or more components. So let us take two component system. So let the components be A and B. And you have Na number of moles of A and Nb number of moles of B. So when you calculate the mole fraction of A, so mole fraction of A is equal to number of moles of A by total number of moles, that is Na plus Nb. If you are going to calculate the mole fraction of B, it will be equal to Nb by Na plus Nb, that is total number of moles. So what we can see here, the components for which you are going to calculate the mole fraction, that component, the number of moles, you will write in the numerator. And in denominator, you will write the total number of moles. That means the sum of the number of moles of all the components present in the solution. Now here, since you have only two components, A, Na, B, you have Nb moles, so the total number of moles is Na plus Nb. Now always remember this, if you have two component system, the mole fraction, the sum of the mole fraction of the two components is always equal to 1. Now for numerical purpose you can modify this formula, because in numericals in the question you will not get directly the number of moles. It will be mass and molar mass. So with the help of mass and molar mass, you will calculate the number of moles of A and B, and then you will use the number of moles to calculate the mole fraction. So let us see a numerical to understand this better. So the question is, calculate the mole fraction of ethylene glycol. Ethylene glycol formula is C2H6O2 in a solution containing 20% ethylene glycol, that is C2H6O2 by mass. So according to this question, you have to calculate the mole fraction of ethylene glycol. Now, it's a solution. So ethylene glycol is the solvent. Now there is nothing mentioned about the solvent. So the solvent is water. So first, write down the formula, that is mole fraction of ethylene glycol, that is C2H6O2, is equal to number of moles of ethylene glycol, that is C2H6O2, by total number of moles, that means number of moles of ethylene glycol and number of moles of water. Now you have here 20% of C2H6O2 by mass. It means you have 20 grams of C2H6O2 in 100 gram solution. So from here we can write Wb, that is mass of solute, that is the mass of ethylene glycol, is equal to 20 grams. So therefore, the mass of solvent, that is the mass of water, will be equal to mass of solution minus mass of the solute, that is 100 minus 20 is equal to 80 grams. So mass of solvent is equal to 80 grams. Molar mass of solute, that is ethylene glycol, you can calculate from the formula, that is C2H6O2. So it's 12 multiplied by 2 plus 1 multiplied by 6 plus 16 multiplied by 2, which is equal to 24 plus 6 plus 32. And this will be equal to 62 gram per mole. Similarly, you can calculate the molar mass of the solvent, that is water. If you calculate, you'll find is 18 gram per mole. Now, number of moles of C2H6O2, that is NC2H6O2, is equal to mass of C2H6O2, that is mass of solute, given 20 gram, by molar mass of solute, that is 62 gram per mole. Similarly, you can calculate the number of moles of water, which is equal to 80 gram by molar mass, that is 18 gram per mole. Now you put the values here in the formula, you simplify, you'll get the answer. So you complete this yourself. Next, we are going to study solubility. Now, solubility is defined as the maximum amount of solute dissolved in a specified amount of solvent. At constant temperature and pressure. So you take a specified amount of solvent, can be 1 liter, 2 liter, it can be any amount, but it has to be specified. That means constant. You will not change the amount of solvent during the course of solubility. So take a fixed amount of solvent, you add solute. Remember, the temperature and pressure should be constant, because the temperature and pressure change will affect the solubility. Now if you keep the temperature and pressure constant, and if you add solute to solvent, initially the solubility will be high. That means the solute will easily get dissolved in solvent. But as the amount of solute increases in the solution, the solubility will decrease. Now you will reach a point where the solute will not be dissolved in the solution anymore. So there is a limit. There is a limit of the solubility of solute in solvent. So this phenomena is known as solubility, that is maximum amount of solute dissolved in a specified amount of solvent, keeping the temperature and pressure constant. Now there are factors which affect solubility. Let us see the factors. So there are 3 important factors. First, nature of solute. Second, nature of solvent. And third is temperature. Now if you take pressure, pressure has no effect on the solubility of solid in liquid. But if you consider the solubility of gas in liquid, pressure has a part to play. That means if we consider the solubility of gas in liquid, the solubility will increase with the increase in pressure. And based on this, we are going to study the next law, that is Henry's law. So according to Henry's law, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas in solution at constant temperature. Say, let us take a solvent, let it be water. And on the surface of the solvent, you'll have the gas, let it be carbon dioxide. Now, according to Henry's law, if we increase the pressure, the solubility of the carbon dioxide will increase in the water. That means more the pressure applied by the gas, more will be the solubility of the gas in the water, that is in the solvent. Application of Henry's law we can see in case of these cold drink bottles. Now you know, in cold drink bottles, carbon dioxide gas is dissolved with high pressure. So as soon as we open the cap of the bottle, the carbon dioxide goes out. Now this is because when we open the cap, the pressure is released, the pressure will decrease. And that's the reason the solubility of carbon dioxide in the solution also decreases. Now it can also be expressed in terms of mole fraction. So Henry's law can be also stated as the pressure of a gas on the surface of liquid is directly proportional to the mole fraction of the gas. Or we can write it as P equal to KH mole fraction of gas. This is the mathematical representation of Henry's law. And for this we can write solubility as directly proportional to P, or as equal to KHP. So thank you. In the next video we'll continue this chapter.